Hey, welcome back. In our last lesson, we introduced Faraday's law of induction. This states that a change in magnetic flux induces an EMF. Let's today see this with some experimental equipment. Here I have 3 coils. Each one has a different number of loops, and they are connected to this needle that will detect if a current is flowing through the coils. What I am going to do is to pass a magnet through each coil. Because of the magnetic field of the magnet, there will be a magnetic flux through the area enclosed by each loop. After Faraday's law, if the magnetic flux changes, there should be an induced EMF in each loop of the coil. Adding up the EMF of each loop will tell me the total EMF induced in the coil. Because I will be moving the magnet into and out of the coil, I will be changing the magnetic flux through the coil, so I should be inducing an EMF on the copper of the coil, and I should be able to measure it. At the beginning, Michael Faraday thought that it was the magnetic field the one to induce the EMF, until he realized it was the change, the important factor. If I do it on the second coil with more loops, the effect is clearer. If I do it on the third one, I see a bigger effect, right when I move the magnet. Let me now try a stronger magnet and see what happens. Look how when I put the magnet inside, the needle moves one way and the opposite way when I take it away. This is because I am changing the flux in opposite ways. I increase it one way and I decrease it the other way. Well, this is Faraday's law in a nutshell. May science be with you.